Today we are going to learn about another design pattern in distributed systems called causal consistency pattern. First of all, we have to understand what is causal relationship. For example, let's say there is an operation A that is happening and after which operation B happens. Now the causal relationship says that A can be causing B or A could have caused B. Okay. So in causal consistency pattern, for example, we are writing some data and then there is a read operation. Then reads can be a cause of writes, that is our client wants to read the data that they have written. Now consider our database where we have 10, 20, 30 values already present in our database and client C1 is writing data 1 in our database. Now this operation has been done. Now the reads are not being done directly on the leader, but we are following the follower reads pattern that we have discussed in previous video, where reads are being done from a follower. This is the follower which is replicating its data from its leader. This is leader, this is follower. Now follower can always be behind leader. It cannot go ahead of leader. So at the moment it has written 10, 20 and 30 values. The latest value 1 has not been replicated on the follower. And when the client C1 is going to read from the follower, it is going to get the latest value of this database as 30, which is wrong in client's context because it knows that it has written value 1 and it wants to get that value from the database. Now here is the problem that is we are trying to solve. So how can we solve this problem so that whenever client C1 is trying to write some data on the database and then causally reading it, it will always get the latest value at that point that it has written or the value that was written at a later point, but not from before. So what it can do is when the client C1 is writing to the database is going to return a version of its value. Let's say the versions of these values are V1, V2, V3 and V4. So this version is going to be returned as V4. Now the client C1, when it wants to read these values from the follower reads pattern, it will do a read query on follower with read V4. Okay. Now follower only has V1, V2 and V3. It only has data till V3, but it does not have data at V4 or at later point of time. So what follower is going to do is it is not going to return the latest data that it has, that is at version V3. It is going to wait this read request till the time version V4 is replicated from its leader. Now when version V4 gets replicated and becomes available, then this follower is going to return this data. It can also be possible that there are more updates from the leader. For example, when client has written V4 and post that client C2 writes another value 2 at V5, and till the time this client issues a read version 4 query to this follower, it has version V5 with value 2. Since version V5 is more recent than version V4, our follower is going to return value of version V5 as 2. It is up to us, and most generally what we do is we want version that is equal to a read request which was V4 or any version later than V4, that is V5. So this is how we can ensure causal consistency, that which is our writer will not get any data which is older than the data it has written by issuing the written timestamp or written version in the read request, subsequent read request. And this is how we solve causal consistency in distributed systems. Thank you.